Hello everyone, welcome to my channel. In this video, I would like to work on two integrals. The first one is this one that you see here. We are required to evaluate the integral from 0 up to infinity of 1 over e to the power x plus 1 dx. The second one is going to be a double integral that I will look at. Now, if you're new to this channel, please don't forget to subscribe. Now, let's look at how we approach this one. I've dealt with a similar one in one of my previous videos. I named that set of questions tricky integration techniques. You may wish to have a look at that, but let's look at how we go about this one. Number one, the integral from 0 up to positive infinity of 1 over e to the power x plus 1 dx. Now, how we deal with this one is to look at this. You can't use u substitution directly here because you're going to land into trouble. This one here, when you differentiate this, it will have e to the power x, and we don't have e to the power x in the numerator. So the way that we deal with this one is to multiply the integrand with a special one. The integrand is this one here. So we're going to say this is the integral from 0 up to infinity, multiply the numerator by e to the power minus x, and multiply the denominator by the same e to the power minus x times e to the power x plus 1 dx. Notice that we haven't changed the integral at all because these can cancel and you're going to be remaining with the original integral that you have there. So this is the same as the integral from 0 up to positive infinity. In the numerator, we have e to the power minus x. In the denominator, e to the power minus x times e to the power x. If you notice, the answer is 1 because you're going to have minus x plus x, which is 0, and e to the power 0 is actually 1, plus e to the power minus x times 1 is e to the power minus x dx. Now, u substitution can work because we have e to the power minus x in the denominator and we also have it in the numerator there. But now, let's go straight into u substitution before we explain how you deal with the infinity there. So I'm going to say let u be equal to 1 plus e to the power minus x. Differentiating both sides, you're going to have du is equal to derivative of 1 is 0. It's a constant. Derivative of e to the power minus x is minus e to the power minus x. And then we have dx here. Now notice we have e power minus x dx. We don't have a minus. So I'm going to have to divide both sides by minus 1. And this one changes to du minus du actually is equal to e to the power minus x dx. Now, this is fine because this one here is what you get over there. But now let's work on the limits now. So now we're going to say what happens to u as x approaches 0. Now, limits, we're going to say as x approaches 0, what does u approach? U approaches 1 plus e to the power minus 0, remember? And this is just e to the power 0, which is 1. 1 plus 1, the answer is 2. Now, let's look at the upper limit. What about and as x approaches infinity? We're back here. As x approaches infinity, e to the power minus x approaches 0, and so you just have u approaching 1 plus 0, which is equal to 1. So now we are fine with limits of integration as well as the integrand, because the integrand now will have to change. Let me rewrite this so you see what I mean. Page 2. So what we have now is the following. What we have now is this expression here, this integral, will have to change in terms of limits and also the integrand. Remember, e to the power minus x dx, I want to put it together. So I'm now going to have that will be equal to the integral of 1 all over 1 plus e to the power minus x. And then we have e to the power minus x dx. I want to put that together like that. Why do I need to do that? Because I want you to see that the denominator becomes u, and this will be 1 there, and this and that will be combined to give us what we call minus du. So now we're going to have changing the variable. This is the integral. Remember, the limits here remain 0 and infinity as long as you still have x there. The limits remain the same. Limits remain the same. Now, in the second part now we're going to say the lower limit is going to be 2, the upper limit is going to be 1. So lower limit 2, upper limit 1, and we have 1 over u, and then we have minus du, like so. Remember, e to the power minus x dx is minus du. And I transformed this, combined these two together, and then we have 1 over this, as you can see here, 1 over that, and then together, and then that is replaced by that, 1 over that, that is u. Actually, we said let u be equal to 1 plus e to the power minus x. There it is. Right, now I'll take the minus outside, so this is going to be minus the integral of 2, the integral from 2 to 1 of 1 over u du. Now, when you have a minus here, you can change the limits of integration. This can be the upper, and that one can be lower, and then the minus is gone. So there's a theorem there that we're using. The limits of integration now will be 2, and down here 1, and the minus is gone. And then we have 1 over u du. Now, the integral of 1 over u is actually natural log of u. So this is equal to natural log of u, and then we are evaluating that from 1 up to 2. Now, if you put in there 2, this will be natural log of 2, and then minus natural log of 1. Natural log of 1 is 0. Our final solution then is natural log of 2. So that's our final solution to this integral here, which looked difficult, but not very difficult because of the special one. I've spoken about the special one in my previous videos, and here it comes out again there. So just be careful when you have been given a question like this to integrate. Especially integration requires you to think first before you can try and use other techniques. Think a little bit more. You will see that the approach may not be as difficult as perhaps the question is suggesting. Let's look at the second integral now that we need to look at in this video. The second integral is this one here, a double integral. Double integral, there it is. I've spoken about double integrals in my previous video. Now this is the second one on double integrals. So in this one, I have spoken about a single integral here, as you saw, and you can see here, and then this one is a double one. Excuse me. So how do we go about this? Well, here is how we go about this. The inner integral is with respect to x because it corresponds to the first variable there, x, the inner integral. In other words, these are x values from x equals 0 up to x equals 1 of this. So we're going to integrate this with respect to x, and then taking limits 0 up to 1 of x, we will treat y as a constant. So y here will be treated as a constant. Y squared there will also be treated as a constant. Once we're done with integration with respect to x, we move to integration with respect to y. Then we're going to use these limits outside there. So the inner integral corresponds to the dx there. Then the outer integral corresponds to dy. Now, here is the approach. So let me capture question number 2 exactly how it is. Integral from 1 up to 2, then integral from 0 up to 1 of what? Of 3x squared y plus xy squared, and we're saying dx and then dy. Right, now changing this, I'm going to transform it a little bit to include the brackets, integral from 1 up to 2 of, I'm going to do this, watch this, integral from 0 up to 1, and then allow me to use brackets here, 3x squared y plus xy squared, and then we're talking about dx first, and let's use brackets there, and then we have dy. Now, integrating with respect to x, remember in this case 3y will be constant, and there y squared will be a constant. So here is how it goes. The integral from 1 up to 2 of what? Of there, I'm going to have 3x cubed over 3. Remember, we add 1 to the power and divide by the result. Y is a constant, plus here the power is 1, so we have x squared over 2. Y squared is a constant. Limits of integration from x equals 0 all the way up to x equals 1. Remember, we have two variables here, so we have to specify that we're actually taking evaluating with respect to x. In other words, x from 0 up to 1 of the two variables. All right. we have dy outside. Now, how we deal with this, remember inside there, the 3's cancel obviously, and y is a constant because we're dealing with x. So these will cancel. Let me take it to step number 2. Maybe from here, that would be my second step. But otherwise, I just want to extend, clean up a little bit, and then take the limit. So this is what we're talking about, x cubed. Let me write y on the left, plus this part here, I'm going to have y squared over 2, and then x squared. And then I'm saying, taking limits from x equals 0 up to x equals 1. And then I have dy outside. Now, this is fine. So now I'm saying this is integral from 1 up to 2 of y is a constant, but there I must put 1 now. 1 cubed plus y squared over 2 is a constant, and I have 1, and I must square it, minus. Then I must put 0 there and there. So it will be y times 0 and all cubed plus y squared over 2 times 0 all squared, like this, and then I have dy. Now notice this is 0 basically. And so what I have now is the integral from 1 up to 2 of, this is just y plus y squared all over 2. This is gone. And what do I have outside there? dy. Right. Now that takes us to page 4 now. On page 4, what do we have? Let me move this one down. All right. Now I'm basically saying that this is the same as, now I'll perform integration. I'll perform integration now, or I'll distribute this and that at the same time. Integral from 1 up to 2 of y dy, and then plus 1 over 2, if you like, integral of y squared from 1 up to 2 dy, like so. Now, what is the integral of y with respect to y? Obviously, it's y squared over 2, and limits of integration 1 up to 2. Remember, now we have one variable. I don't have to say y equals 1 up to y equals 2. And then plus 1 over 2, and what do we have there? We have there y cubed over 3, limits of integration 1 and up to 2. Now 3 is a constant, is dividing. I can take it out, it will multiply with 2. And the same story here. So I can rewrite this as 1 over 2. And then I'm going to say 2 squared minus 1 squared. There. Put 2 there and put 1 in the place of y squared. Then I'm going to say plus 1 over 6. And then I'm going to say, remember the 3 can come out. And then I'm going to say 2 cubed minus 1 cubed. Right. So this is 4 minus 1 is 3. So this is 3 over 2. And then I'm going to say plus. This is 8 minus 1 is 7. 7 over 6. Now let's simplify this. So how we simplify it, I'm going to change this to over 6, multiply by 3 and by 3. So that will be 3 times 3 all over 2 times 3 plus 7 over 6. This is going to be 9 over 6 plus 7 over 6. And the answer is 16 over 6, which simplifies. We can see that 2 goes there 3 times, 2 goes there 8 times. So my final solution is 8 over 3. Right. Now, according to Fubini's theorem, I talked about Fubini's theorem in a previous video. He basically says that the order of integration doesn't matter. Both x is integrable on that interval from 0 up to 1 with regard to this function here. Y is also integrable from 1 up to 2 of this function. And therefore, it doesn't matter whether I start integrating x and then y, or y and then x. I want to repeat that process. Repetition is critical in this story of teaching and learning of maths. Let me change the order of integration. So I'm going to say changing. Remember, our solution is 8 over 3. Let's change the order of integration. Let's see what we get. Taking us to page 5. Now I'm going to say changing the order of integration. Let me put this one aside there for a minute. Right. So I'm going to say changing the order of integration What do we get? We get the following. Watch this. I'm taking this out, this one in, and that one out, that one in. So I'm basically saying we get the integral from 0 up to 1 and the integral from 1 up to 2. We keep this one function exactly the same, plus xy squared, and then now I must have dy dx. There it is. So if you can see there, let me move this one down a bit more. Right, there you go. You can see basically that I have taken this out, this one in, that one in, and that one out. Let's see what we get. Evaluation of this, we need to move a bit quicker now because of time. So I'm going to say this is the same as integral from 0 up to 1. Allow me to use brackets. The integral from 1 up to 2. Allow me to use brackets again. 3x squared y plus xy squared. And then I'm going to talk about dy here. And then I close that bracket and I say dx outside there. Now, integration with respect to y first. What do we have there? Remember, 3x squared is a constant. So what we have now is 3x squared is a constant, and I'm going to have y squared over 2. Remember, add 1, divide. And then plus x is a constant, add 1 and divide by this result. So that will be y power 3 over 3. Limits of integration. Remember, now we have to say y equals 1 all the way up to y equals 2 because we have two variables in there. So we have to specify the variable we're dealing with. I have the x outside. Now let me rewrite this. The integral from 0 up to 1. Watch this. This is going to be 3x squared all over 2, and then I have y squared plus, then I'm going to have, remember we're dealing with y, so x over 3, and then I'm going to have y cubed. Now we're focusing from 1 up to y equals 1 up to y equals 2, and then I have the x outside there. Now, this one goes on as follows. This is going to be the limit, integral from 0 up to 1 of, I'm putting 2 there and there now. So 3x squared over 2, and then I'm going to say 2, remember, squared plus x over 3, and then I'm going to say 2 cubed. Then I'm going to say minus, remember we're done with the top limit, minus, I'm going to put 1 in that place and that place. So 3x squared over 2, and then I'm going to say 1 squared plus x over 3, and then I'm going to say y cubed. 1 cubed. And then I can close that, then close this one here, and then I have dy at dx. Right, now let's clean up this. Taking us to page 6. Page 6. Right. Now let me move this one. All right, so you're able to see. So here we go. Right, now there you go. Right, so now I'm going to say, cleaning up that integral from 0 up to 1 of what? This is 4 divided by 2 is 2, and then I have 6x squared there, and then here this is 8 over 3 plus 8 over 3 x, and then minus this part here is just going to be 3x squared over 2 minus x over 3, and then I have dx. Now these can simplify and those can simplify. Now here I have denominator 2, so I'm going to have to rewrite this integral from 0 up to 1 of 12x squared over 6 over 2, sorry, and then I'm going to say minus 3x squared over 2 plus, here I just have 8x over 3 minus x over 3, and then I have dx. Now this part here I can rewrite it as integral from 0 up to 1 of what? Of 12x squared minus 3x squared all over 2 plus 8x minus x over 3, and then dx. Now this part is 9x squared over 2, so I'm going to have the integral from 0 up to 1 of 9x squared over 2 plus 7x over 3, and then I have dx. Let's distribute this and that and take out constants. This is the same as 9 over 2 integral of x squared dx, limit from 0 up to 1, plus 7 over 3 integral of x from 0 up to 1 dx. Now excuse me, so this one here is going to be 9 over 2, and then we have x cubed over 3 integral limit of integration 0 up to 1 plus 7 over 3, and then we have x squared over 2 limits of integration 0 up to 1. Now remember, this is a constant and that's a constant, so this 3 going into 9 is 3, so what I have is 3 over 2 and then I'm going to say put 1 there, it will be 1 cubed minus 0 cubed, plus this is 7 over 6, and then put 1 there, it will be 1 squared, minus put 0 there, it will be 0 squared. This one here is just 3 over 2 because that's 1. And then here we're going to say plus, that is also 1. So it will be 7 over 6. Now let's simplify this on page 7, and let's see if we get the same result we got earlier on. So this is page 7. So now what we have is denominator here is 6. I'm going to have to make sure that denominator is the same there. So this will be 3 times 3 over 2 times 3 plus 7 over 6. So this is going to be 9 over 6 plus 7 over 6. This is a 9 plus 7 over 6. And yes, that's 16 over 6. And yes, 2 there is 8, 2 there is 3, 8 over 3. So this confirms the Fubini's theorem, which basically says that the order of integration doesn't matter as long as the two functions are integrable on the indicated region. Right, so our first, remember our approach in what we got here is what we got earlier on. Integrating x first, we got this. Integrating y first, we got this. So same result. All right, in this video, I'm going to stop here. Integration still continues. We have so many things to work on. I haven't started looking at applications yet. We're still building skills that are required for us to perform integration in the application process. Now, if you're new to this channel, like I said at the beginning, please support us by subscribing and give us feedback. We truly value your feedback. It helps us in terms of preparation, planning, and presentation of this information that we try to present on this channel. All right, I'll see you next time.